Okay, so today in class, I'm not here, but I'm going to go through the notes just like I would have gone through them with you in class. So we're going to be talking about the stuff that we learned online about atomic orbitals and quantum numbers. So we're going to be talking about atomic orbitals, or more specifically, quantum numbers. And we talked a little bit about these in class yesterday, but we're going to get into a little bit more detail now. So I would take out notes and make sure you're working along with me. So let's talk about our quantum numbers. Sorry, I know I sound gross, but my cold is not seeming to go away. So the first one we have is energy level, which, if you recall, is the letter N. And this has a range from 1 to 7. And the maximum capacity for electrons is 2n squared. And then we've got sublevel, and this was L, and that is an S, P, D, or F sublevels with the numbers 0, 1, 2, and 3 associated with them accordingly. Then we have angular momentum, which the more I write the word angular, the less it looks like a word, which is M sub L. And this has a range. It's directly related to sublevel. So this range is negative L to L. And it's talking about the location within a sublevel. And then we also have spin, which is M sub S. And it's either plus 1/2 or negative 1/2. And so we kind of talked about all of that yesterday, but that's just kind of a quick go over about that. And now we'll talk a little more in detail about each of them. But the key thing to remember is that no two electrons can have the same 4 quantum numbers. You can have 3 of the same, but you can't. That 4th number has to be different. So let's talk about them individually. We've got energy level, which can be found on the periodic table. Okay. And remember, that's kind of going into what Bohr had in mind about those quantized energy levels that the electrons exist in. And we've got energy levels of 1 through 7, and it corresponds with whatever period they are in on the periodic table, or our rows. Not columns, but rows. Then we have sublevel. Okay. And sublevels can also be found on periodic table. Okay, so if this is my periodic table, I'm going to do a crappy drawing, not forgetting my F block. I can divide this up and find my sublevel based on location in the periodic table. Now, this I did not go over in the online notes. This is a little thing that we were talking about in class, and we'll talk more about it tomorrow with electron configuration. But if you're in the first 2 rows, or that tall part right there, you're an S sublevel. If you're over on this side, the right side of the periodic table, you're P sublevel. Our transition metals are a D sublevel. And then those, what do we call them, lanthanides and actinides, that's called the F block. Okay. And And then after sublevel, we have angular momentum. Okay, and it's the location within the sublevel. And it varies. Different sublevels have different numbers of locations. Remember, this is negative L to L. So if you are an S orbital, your L value is 0. Well, there's no such thing as a negative 0 and positive 0, so it's just 0. So it's just one orbital. If you're a P sublevel, your L value is 1, so you have negative 1 to 1, which if we go up by integers, that is negative 1, 0, and 1, or 3 orbitals. If you are a D, you have negative 2 to 2, so negative 2, negative 1, 0, 1, 2, or 5 orbitals. And then if you're S, you're negative 3 to 3, so negative 3, negative 2, negative 1, 0, 1, 2, or 3, which is 7. So negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay? And remember, you can put 2 electrons in each orbital. 2 electrons in each orbital. And then we also have the last one, which is spin, which is either plus 1/2 or minus 1/2, or spin up and spin down. And those are, in fact, half arrows, not real arrows, and that isn't because I'm being lazy, it's because that's how we do it. So let's talk about an example for a second, because this is more what you're going to be practicing with when we do these examples. So what are the quantum numbers for a 3p orbital? So let's talk about it. So n is going to be our energy level. So if we're talking about a 3p, the 3 in front is talking about our energy level. So n is going to be equal to 3. L is going to relate to what our sublevel is. Here we have a p sublevel, so that's going to be L is equal to 1. Then we have m sub L, which is going to be negative L to L, or negative 1 to 1. So negative 1, 0, or 1 are our possible numbers. And then m sub S, which is going to be either plus 1/2 or negative 1/2. Okay, that's pretty much it. Another question I could ask is, what are the quantum numbers for electrons in lithium, for example? So lithium has 3 electrons. It's got 2 in the 1s, and the third one goes in the 2s. And so if we were to look at those electrons, and I'm actually going to so if we were to look at those electrons, that electron, its n value is going to be 1 because it's in the first energy level. Its L value is going to be 0 because it's an s orbital where L is 0. M sub L is therefore also 0. And M sub S for this one is going to be plus 1/2 because it's a spin up. For this guy, you've got n is equal to 1 again, L equal to 0, M sub L equal to 0. There's my first 3 quantum numbers being the same. But M sub S this time is negative 1/2. There's that fourth one that can't possibly be the same. And then if I look at that electron, I've got n is equal to 2 now, L still 0, M sub L is also 0 because it's still an s orbital, and M sub S is plus 1/2 this time because it's a spin up. So this time, the 3 similar quantum numbers were actually L, M sub L, and M sub S. The different fourth quantum number was the energy level. So this is what we're going to be working on today. You've got some practice problems. I'm going to have the sub put out the answer key towards the end, and then we'll quickly go over it tomorrow if you have any questions. Sorry that I couldn't be here, but I have a meeting that I have to go to. So I will talk to you guys tomorrow, and have fun.